So far, we've talked a little bit about how to calculate the spread of data, but we haven't really talked about what the data looks like as a whole. So data can be skewed, and there are some different terms that we use to describe collections of data and the variables that we use to describe the data that we've collected or the variables that we investigate. So the first type of distribution is a symmetric distribution, which is when the data shows a mere symmetry about the center. So you've got an example here, and there are a couple further characteristics or further categories of a symmetrical distribution. So the first one is a U-shaped distribution, and it has peaks at either end, and it's bimodal, which just means that it has two modes or two most common numbers. And this graph would look something like this. So it is U-shaped. Okay, we've got just a general sketch here. And we've got two numbers that are the most common. It's bimodal. And the general shape is a U, which is almost the inverse of the example that we have up here. The next one is a uniform distribution. And that is when each outcome has a similar frequency. And so you can probably picture what this would look like, but we're going to record a sketch here. Basically, all of your bar values would be at the same level, approximately. The third one is a mound-shaped distribution, which is where one bar has the greatest frequency. And the frequencies decrease on either side of that. Okay, so the opposite of our first graph that we drew in this table, so we would have the tallest or the greatest frequency in the middle, and then the bars would decrease on either side of that. This is data that is uniform or symmetrical, so you could fold it in half and it would match. Some distributions are skewed, and where you have the bars with the greatest frequency are grouped either to the left or the right. The direction of the skew is determined by the direction the mean has shifted. So the first example here is right skewed, where the graph, the frequencies are clustered to the left. Sometimes this is also called positively skewed. And typically the mode is less than the median, is less than the mean. In a left skewed graph, which is also called negatively skewed, the graph of the data set is mounded to the right. Typically in this scenario, the mean is less than the median, is less than the mode. So if the mean is the least, that is usually left skewed or negatively skewed. If the mean is the greatest, usually that is right skewed or positively skewed data. When we're discussing graphs, we often talk about mean, median, and mode. This one is probably the most common that comes out, and you want to know which is the most accurate. So the outliers affect the mean the most, as we discussed in a previous video. If the data contains a lot of outliers, you want to describe your data using the median to avoid misrepresenting the data. If the data are strongly skewed, the median, again, may best represent the central tendency of the data. If the data is roughly symmetric, as in our first three examples that we looked at, the mean and the median are going to be close, so either is okay. If the data are not numeric, so for example, color, or if the frequency of the data is more important than the value, then the mode should be used. So that gives you an idea of which measure of central tendency you should use to describe your data. The last thing that we're going to look at in this video is just some terms. So we're going to fill in some terms that you should be familiar with from this unit, and you should be able to use in your descriptions of graphs. And I'll take some of them out because we don't need to do all of them. Data, we don't need a definition for here, but let's look at population. This is a group of individuals that are the focus of the study. The subset of this is a sample, and this is a selection of individuals taken to represent the population. So for example, the population might be the students at Glenview. You could take a sample by taking a few students from each grade proportionally to represent the entire population of Glenview from their responses. An inference is a conclusion about the population made from the sample. Census, you don't need. Oops. Okay, let's do longitudinal study next. So this is a study that considers individuals over a long period of time. And a cross-sectional study is a study that considers individuals from different groups at the same time. We've also got quantitative variables, which are variables measured quantitative, measured numerically. And then we also have qualitative variables, which are variables that cannot be measured numerically. And our final pair that we have here is discrete data versus continuous data. Discrete data is data that is only described using whole numbers. And continuous data is data that is only measurable using the real number system. Which is to say fractions. There. So that gives you an example of terms that you should be familiar with, and then some examples of how to describe data, and some examples of distributions symmetrical distributions, and then non-symmetrical distributions.